Okay, so um, so there's a video here, but I'm not sure we'll be able to play that video now because of time. But let's look at the text that uh we have here. Okay, so the main thing about that we need to know, and I'm sure you would have also observed it, a quadratic sequence doesn't have a common difference. So, in other words, there's a difference, but that difference is not common. Okay? It's not common. In other words, it's not the same through the sequence. So, once you understand that, what it means is that you will expect a difference, but expect that difference not to be the same. So, let me see if I can find an example. Okay, so look at this example. Uh, okay, so look at this first example: 1, 2, 4, 7, and 11. Now, when you look at the difference, in other words, that means something is being added, but it's not that that something is not constant. When you find something that is being added that is constant, then that kind of sequence is an arithmetic sequence. That one is not quadratic when it is constant. In other words, when it is common. That's the meaning of that word common. Okay. So when the difference is common or constant, then you have an arithmetic sequence. But when the difference seems to be changing from term to term, then it's most likely a quadratic sequence. But we don't judge by just looking at it the first time. We need to check some things.
Hello, sir.
Goodness, can you hear me now?
Yes, sir.
Okay, sorry about that. My bouncer fell down and is connected. Okay, can you see my screen now?
Yes, sir.
Okay. All right. So I was just saying that when it comes to identifying quadratic sequences, right? Um, there's a difference, but that difference is not common. So, for instance, if you look at the between 1 and 2, the difference is 1. Between 2 and 4, the difference is 2. Between 4 and 7, the difference is 3. Between 7 and 11, the difference is 4. Now, once you see that the difference is increasing, so that's number one requirement. It's either increasing or reducing. But if it's increasing, that difference is increasing by a steady rate. So in other words, the difference between one term and the other, okay, that difference itself has a difference between, as you go from one term to the other. So that's where you saw that kind of you saw something like this in your notes. Difference between 1 and 2 is +1. Okay, and then between 2 and 4 is +2. That's 2. Okay, and then 4 and 7 is +3. So yes, this difference is not common, but there's another difference between the differences that's common. That's 1. Okay, the difference between 2 and 3 is 1, 2. So when you find this kind of scenario, then you have a quadratic sequence. Okay, now um I think the aspect that we may want to equally look at is the general format for quadratic sequences and how they look. So that was whether ax plus b, ax squared plus bx plus c, came in. That's the typical format of a quadratic expression. Okay. But I want to know if you understood this concept here.
Yes, I do.
Okay. All right. So, um, okay. So I don't know if this one that has a fraction would be easy for you to discern, but is this something that you can handle? Figuring out the common difference, the common second difference rather, for each of them.
It's not hard to do this one. It's just the formula.
Okay, is the formula right?
Yes, sir.
Okay. Okay. So that, but then um, if you had seen a sequence, right, and you were not told that it's a quadratic sequence, you can find that out, right?
Yes, sir.
Okay. Okay. I just wanted to be sure about that. Okay. All right. So let's go back to the top. Mm, okay. So, well, this one doesn't, I'm not sure this one has the workings about the formula. Mm, mm, um, okay. Okay, this one doesn't really have the formula, but I think there's a question here that's um, saying something about the correct nth term rule for the quadratic sequence. Okay. Okay, so let's see if we can get that out on this one. Um, so if we were to find out what's the first difference here between -8 and -5.
That's -3. Oh, 3. Between -8 and -5.
Uh, so how would we find it? If we were to find it, we'll say -5 -8, isn't it?
Yes.
So
-5.
-5 -8 is equivalent to -5 plus 8. So what would that be?
3.
3. So it's just 3. Um, okay. Then when we do for the next one, between -5 and 0 is 5, isn't it?
Yes, sir.
Okay, so I'm sure you can already see the trend. Between 0
Yes,
and
sir.
7 is 7.
7 and
Between 7 and 16 is 9. Okay. So
Yeah.
what would you say is the common second difference?
2.
Exactly. Plus 2. Same thing here is 2. And same thing here is 2. Okay. So the Tn for typical quadratic sequence is given by a n squared plus bn uh, plus c. Okay. Huh. Okay, this is, yeah, a n squared plus b n plus c. Okay. Okay. So which we can use any of the terms, right? Let's use T1. T1 right now is equal to -8. Okay, so we can have it at -8. That's going to be A plus B plus C will give us -8. Okay, so do you know how I got that first equation?
Oh, yes.
Okay, so I just substituted 1 there. And okay, so let's go for the next one. Maybe we should. Okay, yeah, no, this is fine. Um, let's see. The next one is going to be -5. Um, that's T2. T2 is -5. So that means um for T2, which is -5, we'll have that that's going to be 4a because of the n squared. 4a plus 2b plus c equals -5. Okay. All right. Then now, if you can see my what do you call it? I'm having three unknowns now, right? I'm having three unknowns. So that means I'll have to have three equations. So maybe I should do T3 so that would come out. So T3 is equal to 0, right? And then we have that We have t plus 3b plus c equals 0. Okay, so I'm looking at this so that we can figure out the best way to go about it. Something that seems to be common among all of them is that I have C in all of them. C is standing out. Is there any way we can take advantage of that?
Mm. Wait, say again so I can understand.
Okay, I said in this case, have you ever solved an equation that had three unknowns?
Do you know like sub like the terms first and then the answer we use it to guess it?
How do you mean?
Like we're going to find A and B. We
Mm,
haven't done it, so I don't understand.
mm, okay, okay. I'm thinking that, well, three unknowns. Well, okay. Um, okay, let me see. I think I let me see if I can get back to that uh the one that you sent me. Then I'll see the difference if they look different from uh don't think this. uh, hmm, okay. Let me find it like this. Uh okay. Okay. I can't find that note that you sent me about quadratic equations, but let me see.
Maybe I'll send it another day. Should I send it now?
Okay, okay. You
I
can
should
send
send
it.
the
Let me
quadratic.
see.
What should I send? Okay, the quadratic.
The note, the
Okay.
one that you shared with me back then.
Okay, sir.
Hmm. Now so that's because I know that the questions look like similar to this, but it's just that this one is giving us three unknowns when we should have at least two, so that it doesn't become too complex. You can see that. Okay. Oh, okay. Okay. I think this is yeah. All right. Okay. Mm, okay. Okay, goodness. Um,
Uh,
yeah, I see what you sent. Um, but we don't have the examples for this one. Do you
I
have
sent a new
I
one.
think, okay, you sent another one. Okay. All right. So yeah. Um, this, okay. 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 So I see why it will not give us a three um equations. I see how that comes about now. So the A is half of the second difference. Okay. Mm, okay. And B. Okay. Okay. That I think I can see it now. Okay. So we already know A. That's why we will not need to will not need to um have it in the equation. So like this one now only gave us two equations. Okay. Okay. That's fine. I think I can navigate it this way. It's pretty straightforward. Okay. Um, okay. All right. So let's see. Let me go back to that. Okay. So if I have my let me see if I can get that guy back. Mm, okay. So the implication of this is that we will not need that third equation. So let me just undo that third one and focus on the first two. Okay. All right. So this, I think we can work with this. Um, should I just undo all of them until I get something that looks okay? Okay. Okay. So if we recognize that A, where is it? 2A based on um the general formula is equal to the second difference. So in this case, what would you class as the second difference? What what number is the second difference? I think it's our two, right?
Two, yeah.
Two is our second difference for this one. So that means that A will be 1 because if I divide both sides by 2, that's 2A equals 2. We'll have that A is equal to 1, right? 2 will divide itself. Therefore, A is 1. Okay, so that makes it simpler. A will be equal to 1. So if we put A equals 1 in these two equations, it makes things easier for us. For instance, from this first one, you have that 1 plus BC equals minus 8. So you have that, let me see where I have space. B plus C will be equal to, okay, let me move into somewhere that I have more white space. Let me back up from this. Held ones. I was annotating, but let me just use, yeah. Okay, you can still see my screen, right?
Yes, sir.
Okay, well, I'll have to reshare. Just give me a minute. Let me set this guy up. The paint. Okay, where is it? All right, so I can share now. Okay, can you see my screen now?
Yes, sir.
Okay. All right, so let me see if I can move the question in there. Um, it was -8 and -5, 0, 7, 16. Yeah, okay. And then we have dot 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 showing that it continues. Okay. All right. So we said first things first. The second uh, common difference is equal to 2a. So that will help us to find a. So we can say therefore a is 1. Okay. All right. So you know why this is 2, right? You know why the second common difference is 2, right?
Yes, sir.
Okay. Let me see. I want to be sure I heard you very well. I'm coming. Please give me a minute. You can hear me now, Abby?
Yes, sir.
Excellent. Okay. So I was saying I just wanted to be sure I heard you. You know why the second common difference is 2 from what we did back there.
Yes, sir.
All right. So let's continue. So now A is equal to 1, and that means that um where you have T1 equals -8, right? Then we can conclude that instead of and then this is our general formula: a n squared plus b n plus c. This is the general formula for the nth term. This is the general formula for Tn, for a quadratic sequence. Okay, where we know that a is equal to, in this case now, 1. So all we now need to do is to put our 1 there. 1 1 times 1 squared, right? 1 squared,
But
that's 1. Okay. Plus b times 1 is b. So this what I was saying back there. And then c is on its own. It's not adding anything. All this is equal to c1, which is -8. So we can collect like terms. Move this everything. This one, we move it all to make -8. So that means that therefore b plus c equals -9. You agree with that, Abby?
yes, sir.
Okay. All right. So that's the first equation. That's our first product, simultaneous equation. Sorry. Okay. Now, because it's a simultaneous equation and there are two unknowns, we'll need a second equation. That's why we go for T2. So the same thing we did with that T1. T2 will be equal to minus 5. That's the second term. But then let's now look at what the general formula is. The general formula is also going to start with A, which we already know is 1. Okay. But then the n squared is what? 2 squared. So we know that that is 4. So let's just keep that on the side. Then Bn, in this case, n is 2. So Bn is the same thing as 2b. And then finally, plus 2. All this is equal to minus 5. Okay. All right. So the next thing we're going to do now is let's clear this first slide. 4. The 2 squared is 4. 4 times 1 is 4. So we're going to move that 4 to meet minus 5. The same way we did for the first one. So that means our next line is going to be 2b plus c equals minus 5 minus 4, which is minus 9. Interesting. Okay. So all this is equation 2. Okay. So let me see. Let me see if I remember. You told me back then that you prefer elimination method, right,
Yes, sir.
for solving simultaneous equations. Okay. So let's put equation 1 directly beneath equation 2 and see how things play out. Okay. All right. So funny enough, both of them are equal to minus 9, minus 5, minus 4, minus 8, minus 1. This is equation 1. Okay. So let's use elimination method here and take things out. So we want to eliminate C and find B. Why? Because the coefficients of C, they are the same. Okay, it's the same in magnitude. They don't have to be the same in the sign. Okay, but somehow here too they are the same in the sign. So because they are the same in sign and magnitude, subtraction is perfect. So let's see how this plays out. 2b minus b is b. Do you agree with that?
Yes, sir.
And then on this side, I have minus 9 minus minus 10. That is minus 9 plus 9, which is what? 0.
You.
Okay? So now we know that B is 0. I think we can equally find C. Now the good thing about C now, that we can find it from either equation 2 or equation 1, any one that you wish. Equation 1 lends itself as being the simplest to find C with. So let's just use it. So in equation 1, we'll just put 0 for B plus C equals minus 9. Okay? And then, what do we have here? We'll have that therefore C will be equal to what? C will be equal to minus 9.
Plus
Because by the
9.
time you take it, it doesn't make any sense. It's still the same thing, isn't it?
Yes, sir.
Okay, so the general formula for this particular one, I think that's the aim. We are going to put in all the things that are going to be put in. We'll have A is 1. So let's go back to here. So this is the general formula. Let me bring it closer here. So our A is 1. So that means it's just going to be what? N squared plus B is 0, isn't it?
Yes, sir.
So you can just, this is just for putting sake. And C is minus 9. So you can now see what's going to happen. The final answer will be n squared minus 9. That is our Cn. Okay, so did you get it now?
Yes, sir.
So I think the
Yes, sir.
main okay, sorry. So I think the main thing is once we establish what A is, it seems it's going to be from then on. All we now need to do is to look for the general formula, put in the other one, um, put in the A, and then find the other one using synchronous equation, then come back to the general formula and slot in the values for B and C and A. So, do you understand the steps involved now?
Yes, sir.
Okay. So this thing about certain things. I think certain topics. I think your confidence builds up as you do more questions in it. But now let me so that I just want to be sure that we've overcome whatever was the challenge in this with this quadratic sequence. Would you say that what you didn't understand before about quadratic sequence is much clearer now?
Yes, sir.
All right. Okay. All right. So you said you guys are doing functions now, right?
Yeah, but functions is actually easy because it's just subbing in
Okay.
and then
Okay. Can
subbing.
you? Okay.
But when we
Okay.
get to the other parts, I'll just tell you.
No problem. Okay. So I'll send you this the working
And
for this.
yeah,
You may not need
can
to.
you give me like some questions that I can like solve for like homework?
Okay. 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 That's fine. All right. Yeah. Sure. So do you have a book you want to take down the questions with, or okay, let me see. If it's something that I can send to you via WhatsApp too, would that be okay with you?
Yes.
Okay. All right. Okay. Mm, okay. Mm. So let's see. Okay. So I'm going to send you. Yeah, I think I've seen the one I'll send. So yeah, I'll send it as an email. So I'll screenshot and send it to you on WhatsApp. Okay. So, do you think that with this example that we just did now, you can do the questions by yourself, or you would like us to do one more?
I mean, let's do one more.
Okay. All right. Okay. All right. So let's do one more. Okay. Let me see. Hmm, okay.
So this is a quadratic sequence 21, 20, 33. Let me write it down. 21, 26, 33, 21, 26, 21, 26, 33, 42. I think I got it. Okay, so take a look at this. Would you say this is a quadratic sequence? Does it have all the things that make it a quadratic sequence?
Is that 26?
Yes, 26.
Okay. Oh, yes.
It's quadratic, Abby?
Yes, sir.
Okay. All right. So, of course, it's I think we need to establish it second common difference or common second, no, second common difference, right? And call it what it actually is. Okay, common second difference. I think we better to call it the right thing. Common second difference. Okay. All right. So the first difference is the one we're establishing now. 26 plus 7 is 33. 33 plus 9 is 42. So the common second difference is 2. Okay. So, all right. So in this case, the common second difference is 2. So again, I think the best starting point is to conclude what your A is. Okay. And 2A is equal to the common second difference, which in this case is 2. So just like the example above, it's not always so, but well, you can say therefore A is equal to 1. So since A is 1, um, our Tn, right? Maybe our Tn should even start looking like what it is really from the beginning. So, okay, no, let's write it out. An squared, even though we know that the A is 1, let's still write it. But the ones that we don't know are B and C, and then C. Okay, so here we go. All right, so what do we have for the first term? Remember the process. Establish what your A is, then get simultaneous equations for the next two. So that's what we're going to do next. So we'll start with C1. Why? Because it's simpler. It's better to always start with the first thing. Okay, so C1, according to our equation, will be equal to what?
21.
Oh, sorry. The number I should have written first. Yes, 21. 21. So we can now go ahead and do the substitution. So that's going to be one one squared times one again, right?
Yes, sir.
Plus b plus c. All this is equal to 21. So we got this part figured out. I almost wrote my name. Okay. So what that means is that B plus C will be equal to what? 21 minus 1, isn't it?
Yes, sir.
Which is 20. And then this will form our equation 1. Okay. All right. Okay. All right. So can you figure out C2 will be what?
82, that'll be 26.
26. Okay. Okay. And then if we substitute things, right, we'll have 2 squared, isn't it?
Yes, sir.
That's for n squared. Still times 1, which is our a, uh, plus 2b, right? Because
Yes,
of
sir.
the bn, and then plus c, plus c. And all this is equal to what? 22. Okay. Okay. So the next thing we'll now do is what? We know that 2 squared is 4. 4 times 1 is 4. We'll move that 4 to where 26 is to give us 26 minus 4, which is 22. Uh, yeah. Okay. So this is our equation 2. All right. So elimination method is this, right? Single elimination method. It lends itself nicely to this one, especially where C, the coefficient C is the same. Coefficient of C is the same thing. Okay. So we'll simply subtract. And what will we have? 2b minus b again is b.
B.
22 minus 20 is 2.
Mm.
Alright?
Yes,
And
sir.
since b2, we can say from equation 1 that 2 plus c is equal to 20, isn't it?
Yes.
From equation 1, sorry, not equation 2. Okay, I didn't label it. That's why I made a mistake on it. So b plus c equals 20. Uh, so that means that therefore c will be equal to 20 minus 2, which is 18. Okay, so that makes it done. So we now know b is 2, c is 18, and a is 1. So we can now come here and put in our value in, and we'll see that cn is equal to what? Is equal to n squared, because
Good.
a is 1. Yeah, n squared plus b was 2. So that's going to be 2n. And then finally c was 18. So that's going to be 18. Okay, so you're good with this?
Yes, sir.
Okay. All right. So I will maybe if we have space, then I think I can. I'm thinking maybe I should put the questions for you to solve here too. I'll screenshot it and add it so that I'll only send you one one file. Yeah, I'll put it inside this one. And we seem to have quite some space here. Okay. So, do you have any questions, or all your questions have been answered as far as quadratic equations?
Yes, sir.
Okay. The quadratic sequences. Okay. All right. So let me ask you, how would you do this particular question? This one, I wanted to give it to you as one of them, but let me see how you would go about this question. The question says, oh, that was the one. Okay, all right, no problem. It's uh, it's actually okay. It's going to be straightforward. So the question was actually for this one, right? Where it says, what is the tenth term of this sequence that we just saw? The tenth term. So all you need to do is to substitute 10, isn't it? Where you have n.
Okay. 10.
That's yes. Once you substitute 10, you're good. It will give you it will give you what is T10. That's the term at position 10. It will
So
give
we
you
are going to
the
sub the 10. Is it?
yes,
Am I going to sub it to the n squared too?
yes. So this how
Okay.
it will look. T10 will look something like this. 10 squared plus 2 times 10, right? um, plus 18. Okay. So that's going to give us 100
98.
plus 20 plus 18, which is
Oh,
100 and that's 38.
130.
And I'm going to be equal to 128. 138. Okay. So yes, that's it. So I think solving it like this is easier. Um, I'm thinking that someone else would have said, okay, if I know the pattern like this and they're asking for the 10th term, right? Can't I just continue it? So if they wanted to do that method, this is what they would do. Since the common second difference is 2, we will do 9 plus 2, 11. So you see this one, the absurdness of it is that you have to find the next difference from the common second difference before you can find the next term. And the next term will be 42 plus 11, which is 53. Do you understand?
Yes, sir.
And the person, you have to keep on doing like that. to- Okay, so common second difference again is 2, which will make here to be 11 plus 2, 13. 53 plus 13 should give you
15,
the next one, which is
66.
56, right?
Yes.
Okay. So let me ask you, does this method look convenient? Look at how many times we have to go. One, two, three, 4, 5, 6. We've only done 6. But anyway, let's just do it like an exercise if we have to. But I'm sure you know that for large terms, for large terms like say 300, you can't do this. Just
Yes.
imagine you doing it 100 times. It's going to wear you out, and you won't even have time to answer all that question. Okay, so 13 plus 2 is 15. So that 55, 56 plus 15 to give you the next 10. 6 plus 5 is 11. 6 plus
81.
1 is 7 plus 1 8. That's 81. Okay, that's correct, isn't it?
Yes, sir.
81. And we do that again. 15 plus 2 is 17. Yeah, 17. And 81 plus 17 is 98. 98. Okay. How far are we away from this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we need 2 more. Okay, so 17 plus 2 is 19. And 98 plus 19 is what?
107.
9, 107. Okay, thank you. I said 107 or 117.
Oh, yeah, 117. Sorry.
So I think we need to go one more time. 19 plus 2 is 21. And 117 plus 21 will
138.
actually give us 138. So yes, that's the 10th thing. Now, I don't know whether you can notice any difference between what we did now and um using going to use the general formula. Which one would you say is convenient?
The general formula.
General formula. Okay, okay. That's a good choice to make. All right. Okay, so yeah. Okay. You got any other question?
Yes, sir.
Oh, okay. All right. So I think with this you can do the other questions, right? The questions I
Yes,
will
sir.
send. Okay. Okay. All right. See. So I think we can take this for the city our class. Okay. So on Thursday, we'll meet at the same time. Like I said, it's for February. My schedule slightly changed, so move my all my classes by 30 minutes. So yeah, that's the way it is. But I believe by March I should be able to go back to my regular schedule. I don't know. We'll continue with our class time at 5:30. Okay. All right. So, yeah, I think we can. Okay. So, I remember you said you were on break on Monday. That's yesterday, right?
Yes, sir.
Okay. Okay. All right. Okay, that's fine. What else did I want to ask? The other days, remember the other days that you said you may have some free time. Just remember to like give me an idea before then so that I'll know um I'll be able to see if I can plan around them.
Okay,
Maybe
sir.
like 2 days advance or that kind of thing. Okay. All right. So you can enjoy the rest of your evening.
Thank you, sir.
Uh,